This video is for class 8 physics, and today we will learn rules for making the ray diagrams in a spherical mirror. So we are learning this, right? Rules for making ray diagrams in a spherical mirror. Number 1, the object is kept in front of the reflecting surface on its left side only. So uh, let us try to understand what does this particular statement means. So whenever we are trying to draw one ray diagram, either it be a concave mirror, right? Either it be a concave mirror, okay, it needs to have a pole, then it will have this principal axis, it will have the focus, it will have the center of curvature, right? The rule is that you need to keep the object always on your left hand side. Okay, so suppose this is the object, this arrow is the object, then it needs to be placed always on the left hand side. So this is the meaning of the first rule. Okay, rule number 1, the object should be always placed on your left hand side of the mirror. Okay, either it be a concave mirror as shown here, or it might be a convex mirror. It might be a convex mirror. In both the situation, right, in both the situation here, we need to keep the object always on the left hand side, right? So I hope you have understood the first rule for drawing the ray diagram. Let us go to the next one. Rule number 2, the object is always kept on the principal axis such that it is perpendicular to the principal axis and its foot touches the principal axis. Like the diagram which I had drawn before, as you saw that the arrow was facing upwards and the arrow was always placed on the principal axis. Okay, let us do it again. So let us draw for a concave mirror. This is a concave mirror, right? So this is the principal axis, suppose this is the pole, this is the focus, and this is the center of curvature. Then the object should be always placed on the left hand side, and number 2 says that it should be placed above the principal axis. It is placed above the principal axis, not below. It should not be placed in this fashion. So this is the right way to place the object whose image has to be drawn. So I hope you have understood. You can place anywhere on the principal axis, anywhere on the principal axis, but not below, right? These are the few rules we are following in order to draw the ray diagrams. But in reality, the object can be anywhere, either below, above, left side, right side, it does not matter, right? Let us go to the third rule. The third rule says that for constructing a ray diagram, take at least 2 rays of convenience whose paths can be traced after reflection. So to construct a ray diagram, we need to take at least how many rays? 2 rays, right? At least. You can take more than 2, but 2 is the minimum, right? So that 2 in that 2 rays should be, sorry, the convenient rays, this convenient rays here, which we shall study after some time. So these are 3 rules to be followed. I hope it is clear, right? Now to construct the image of an object due to the reflection by a spherical mirror, any 2 of the following 3 rays can be constructed according to our convenience. So we are learning about the convenient rays now. The third point, okay, the convenient rays are: number 1, a ray passing through the center of curvature is reflected along its own path. We shall understand this by drawing. The diagram is important, not the whole paragraph. Okay, so paragraph just explains how it should be drawn. Okay, let us go to the figure. Okay, so this is the figure here, right? So and this is the convenient ray, the first convenient ray for concave mirror and the first convenient ray for the convex mirror. So the first convenient ray is that a ray passing through the center of curvature. A ray passing through the center of curvature needs to get reflected back along the same path, or a ray appears to pass through the center of curvature gets reflected along its same path in case of convex mirror. So this is the first convenient ray. Okay, the ray, we can take any ray, but the convenient rays will make your diagram look better, and your work will be easy. Now the second convenient ray, the second one, a ray parallel to the principal axis. Okay, a ray parallel to the principal axis. So let us see the diagram, what happens to the ray parallel to the principal axis. Here is the diagram. Okay, let me zoom a bit. Right, so a ray parallel to the principal axis, right, in case of concave mirror will be always passing through the focus, and a ray parallel to the principal axis after reflection, okay, what happens is it appears to come from this point focus, right. So a ray parallel to the principal axis after reflection passes through the focus, and a ray parallel to the principal axis after reflection, right, appears to come from the focus. So this is the second convenient ray which we can use for our ray diagrams. Let us go to the third one. The third one is a ray passing through the focus. A ray passing through the focus, it is just opposite of this. Okay, right, a ray passing through the focus, here is the diagram. So a ray passing through the focus, suppose a ray passes through the focus, right, that is my incident ray, strikes the surface and then suffers reflection. So when it gets reflected, this ray needs to be parallel to the principal axis. That means this is just opposite of the previous case. So whenever the ray was parallel to the principal axis here, right, it was passing through the focus, and if the ray passes through the focus after reflection, it needs to be parallel to the principal axis. So I hope this is also clear. And in this case, if a ray is appearing to pass through the focus, although it cannot go here because this is opaque, right, so if it appears to go through the focus, then after reflection this particular reflected ray becomes parallel to the principal axis. It becomes parallel to the principal axis. So these are the three convenient rays which we need to use to draw our ray diagrams, right. So I hope this is clear, you have understood till here. Okay, now going to the next part of the video, which is actually this virtual images and real images. Okay, virtual and real images, right. So real and virtual images, if the reflected rays actually meet, like in case of your concave mirror, the rays were actually meeting, right, they were converging and meeting at a point called focus, right. So at that time when the rays actually meet, okay, the image formed because of this reflected rays meeting at a point is known as a real image. But if the reflected rays do not meet, like in case of a convex mirror, the rays were going away, so they will never meet, but they appear to come from one point, right, or appear to meet at one point, so in this case, whatever the image is created by producing those rays backwards, the image becomes virtual. A real image can be obtained on a screen, but a virtual image cannot be obtained on the screen. For example, when you see your image in the mirror, then that is your virtual image. But if you see a movie on a screen with the help of projector, like your smart board, the white part, okay, where the projector's rays falls, then that will create a real image. So a real image is inverted, but a virtual image is erect. So you can argue me while watching the videos on the smart board, the image is not inverted, because inverted image is already created in the projector, which is further inverted, thus we see a proper image, an upright image on the screen. But the virtual image is always erect. Okay, like for example, the head of a person will be at the top and the feet of a person will be at the bottom only, right. So distinction between the real and virtual images. Real image, a real image is formed when the reflected rays actually meet at a point, whereas a virtual image is formed when the rays reflects and appears to meet or appears to come from one point, or when they are produced backwards they meet at a point. So this is the definition of real image and virtual image. Okay, that is the first difference. The second difference is that the real images are always inverted, whereas the virtual images are always erect or upright. Number 3, it can be obtained on the screen. The real images can be obtained on the screen, whereas the virtual images cannot be obtained on the screen, right? So I hope you have understood. We shall use this convenient rays and the rules for the making ray diagrams in the next video for the images formed by a concave and convex mirrors.